quantum mechanics. Before going to start, if you are new to my channel, please subscribe my channel. Okay, let us start. So what are operators? In physics, an operator is a function over a space of physical state onto another space of physical state. That means operators operating on one function transforms into another function. So some of the operators for physical quantities has been given here. So position, that is denoted by x, okay, and then linear momentum I h cross dou by dou x operator, and it is symbol is px. So this is in one dimension. Like that you can write in 3 dimension. Kinetic energy minus h cross square by 2m dou square dou x square. Potential energy and total energy, that is sum of kinetic energy plus potential energy. These operators you have to keep in mind. Then what is commutation bracket? Commutation relation you should remember. So it is usually denoted in square bracket. Let us take a comma b. How we can write the commutation relation here? A b minus b a. So a and b commute if this square bracket of a comma b is equal to 0. Then ab is equal to what? Ba. If anti-commutator, then this there will be a plus sign, ab plus ba. If in some another case a comma b c has been given, then how we will write the commutation relation? A comma b square bracket into c plus b into a comma c. Okay, then let us take one example here. What is the commutation relation for p comma x? Wave function operating on this commutation bracket. So p comma x, like a comma b. So how we can write? Px minus xp. What is the operator for p here? I h cross dou by dou x, negative. We can also write like this. Here minus I h cross dou by dou x, operator for momentum. We can write h cross by I. So just substitute the operator value for p here. Then what you have to do in the next step, just take h cross square divided by I common. What is left inside the bracket here? Psi of x plus x dou psi by dou x minus x dou by dou x. These two will get cancelled. What is left here? H cross square divided by I psi of x. So this is the commutation relation for p comma x. Like that you can just reverse here, x comma p. Okay, then you can have here x comma p, that is I h cross. Okay, here you got negative I h cross, here plus I h cross. So like that you can write the commutation relation for y comma py and z comma pz. Okay, next, what is linear operator? If an operator A is said to be linear, this is the condition for linear operator: a caps constant c into psi of x, or c a cap psi of x. This is for one dimensional. If you take the second condition, a, there are two a functions, psi1 of x, psi2 of x. You can also write the linear operator. So all quantum mechanical operators are linear in nature. So the properties of commutator bracket, you should remember here: a comma b is equal to what? Minus b comma a. Then a comma b plus c plus d, you can just write in this equation. These properties you should remember. Okay, first you should write down, practice them. Then let us take one example here. Commutator bracket of a comma b comma b comma a. So here inside this commutation we have again a commutator bracket a comma b, b comma a. How we can solve it? First what you have to do, first write the commutation relation for these two given brackets inside, a comma b, b comma a minus b comma a comma b. Then a comma b is what? ab minus ba, b comma a, ba minus ab. Like that you have to write for this second term. After writing the commutation relation, just multiply these two brackets. Then what you will get? Final answer here. All the terms will get cancelled here. So final answer you will get here 0. So this is the answer for this equation. Find the commutator bracket for x square p square. So here we have solved x comma px. So here x square p square. What you have to do here? First let us take x square comma p square. Then x square comma p square. How can you can write p into p. Okay, x square p. Just take it as a, like a comma b. Okay, then write ab minus abc, like that. X square comma p, outside the bracket p, p bracket x square comma p. Then what you have to do here? Just x square is there, so you can just write the derivative of that, 2x inside the bracket x comma p, that is into p. So like that second term. What you have to do here? Take 2 x comma p is what? Earlier what we have got? IH cross. So here you can take 2 IH cross common. So inside the bracket what we are left with? xp plus px. Okay, so this is the answer for the commutation bracket x square comma p square. So the next question, h is equal to p square divided by 2m plus v of x. Then calculate x comma commutation for x comma x h cap. So first you have to write the commutation relation for x comma h cap, that is what? X comma p square divided by 2m, that is h is what? Total energy, Hamiltonian, p square divided by 2m plus x comma potential energy v of x. Then 1 divided by 2m you can take common in the first term, x comma p x square you are left with. The second term, commutation of x comma vx is going to be 0 because they are related to position. So commutation of that is going to be 0. The first term that we will have here is 1 divided by 2m and derivative of p square, that is 2p x comma p. X comma p is what? IH cross. So answer for this commutation relation for x comma h cap is what? IH cross divided by m p. Then substitute this value of x comma h in this commutation bracket. Then again you have to commute. So if you solve this, you will have here the answer IH cross divided by 2m. Inside the bracket you are going to left with x comma p. So x comma p is what? Again IH cross into IH cross minus h cross square by m. So like that you have to solve the given problem related to commutation relation using operators. So next, Hermitian operator. This is very important. Every time one question will be there on Hermitian operator, so you have to concentrate on this. Operator a cap is said to be Hermitian if a dagger is equal to a. Okay, a cap dagger is equal to a cap. and it should satisfy the following relation. Direct representation, we can represent like this: expectation value of A operating here get psi, phi and psi. So this is direct notation of Hermitian operator. And Schrodinger representation, phi comma A cap psi. So integral we have to take here, psi star A cap psi d tau. So these two relations you should remember: direct representation and Schrodinger representation for Hermitian operator. What is Hermitian operator? A operator is said to be Hermitian if A dagger, that is A cap dagger, is equal to A cap. Okay. What are the properties of Hermitian operator? Hermitian operator is always real. Okay. Then second condition, eigenfunctions corresponding to different eigenvalues of Hermitian operator are orthogonal. Okay. Then all physical observable in quantum mechanics are represented by Hermitian operators. These three properties you should remember. First one, eigenvalues of Hermitian operator are real. Eigenfunctions corresponding to different eigenvalues of Hermitian operator are orthogonal. All physical observable in quantum mechanics are represented by Hermitian operator. So let us take one example here. Whether momentum P is Hermitian or not. How we can check? What is the condition here? Direct representation or Schrodinger representation. If we take here phi comma P, we are taking momentum Hermitian or not, P psi. Then how we can write it in terms of integration? Minus infinity to plus infinity, phi star minus I h cross. What is the operator for momentum here? Minus I h cross dou by dou x psi dx. Then integrate this, minus infinity to plus infinity, phi star minus I h cross dou psi by dou x into dx. So from this condition we can say that momentum operator Px is Hermitian in nature. Similarly, we can say that dou by dou x is anti-Hermitian. Okay, anti-Hermitian means negative of that minus dou by dou x. Then what is projection operator? Operator is said to be projection operator if, as we have the condition, A cap dagger is equal to A cap, or square of that is equal to A cap. So these are the properties of projection operators. Eigenvalues must lie between 0 and 1, and product of two projection operators is going to be 0, and sum of two projection operators is going to be 0. So the next, unitary operator. An operator A is said to be unitary if A cap dagger is equal to what? A cap inverse. Okay, this is unitary operator. Then parity operator. Parity operator corresponds to space reflection about original. That means P cap of psi of x is equal to what? Psi of minus x. In general, we can write it in terms of psi of r minus psi of r reverse. Parity means it denotes the sign plus or minus. Then when parity operation acts on a wave function, so what happens? Cartesian coordinate system, we can have x, y, z, that is minus x, y, z. Spherical polar coordinates r, theta, phi. Then cylindrical coordinates rho, phi and z. Okay, so these three systems you should remember for parity operators. Properties of parity operator: eigenvalues lie between 1 plus or minus 1, and odd and even parity, how we represent here? Just you can remember these equations. Parity operator is Hermitian in nature. Parity operator commutes with Hamiltonian operator. These three properties you should remember. So these are different types of operators, but one of the important is here Hermitian operator. Also you should concentrate on these different types of operators. So let us solve some problems here. Prove that the operator I dou by dou x and dou square dou x square here are Hermitian. So what is the condition for Hermitian? There are two conditions here, direct representation or Schrodinger representation you can take. So let us take here, we have taken here Schrodinger representation. So first what we have to take, this is the operator they have given, two operators they have given here. First let us take this one, minus infinity to plus infinity psi n star I dou by dou x psi n dx. Okay, then just take I common here, psi n star psi n minus infinity to plus infinity, that is minus infinity to plus infinity psi n star dou by dou x psi n star dx. What we will get here, minus infinity to plus infinity. What we left here, I dou by dou x psi m star. You can just take the conjugate of that. Here minus here is equal to is there. Sorry, this is minus sign. Then in the first term, if you put the limits, what will happen here? This is going to be 0. Then the second term, it is going to be minus infinity to plus infinity I dou by dou x psi n star, nothing but conjugate psi n dx. From this relation we can say that I dou by dou x is Hermitian. So the next second term, that is dou square dou x square. Like for first term you have to write in terms of Schrodinger representation. Then first condition is what, psi m star dou by dou psi n minus infinity to plus infinity. Then second term will be what, minus infinity to plus infinity dou psi n by dou x dou psi m star by dou x dx here. Then here again we will have the condition after equating the equation minus infinity to plus infinity dou square dou m star divided by dou x square psi n. That means the second operator is also a Hermitian. So you have to check whether the given operators are Hermitian or not. You can use direct representation or Schrodinger representation. Then final equation you must get like in this equation, a cap psi star psi dou tau. If you get the final answer for the given operator, then you can say that that is Hermitian. Find the following commutation relation. So first condition they have given dou by dou x dou x square. If you write the commutation relation for this, how you can write, like a comma b, ab minus ba, you should write like that. Then after equating, what you will get here, answer is going to be 0. Second condition, dou by dou x f of x. So that is like a comma b. You can just write ab minus ba. This is like a comma b. Okay. If you write the commutation relation here, the answer is going to be what? These two terms, after equating, they will cancel, and the answer is left with dou f by dou x sine. So like that you can try to solve the problems related to operators and commutation bracket. First you should know operators for a physical quantity, then what is commutation relation you should understand. Then you can solve the problems related to different types of operators like Hermitian operator or linear operator or projection operator, but Hermitian operator is very important as per your exam purpose, and also commutation relation. I hope this video is helpful for you. If it is helpful, please like, share and subscribe my channel. Thank you for watching.